Surprised I've not killed myself over that yet. So real quick, here's an example of what they're asking. So if I said, here's function, can you figure out, first off, let me just ask this question. Can you see what's the inside piece? What's the inside piece? No. Yes, there. Could be, and why does it make sense for me to say the inside piece is x minus 8? Because x minus 8 is inside of a square root. So there's an inside function, and there's an outside function. Does that idea make sense? All right. So if I ask you, h of x came from what? What did somebody put into some other function? What are these two functions? Well, g of x, is that the inside or the outside function? Where is it?
Inside.
Inside. So that's the inside function. What did we just say the inside function was? X minus 8 was put into what function?
Square root.
Square root. There. If I put this into this, doesn't that make this? So put that into this makes this. That's the way to think about those problems. Those are the problems 12.1, starting with 31. I love you guys. So again, another... Yes.
Okay.
So another example. I should have asked for some more markers standing out. How about... Alright, this one might be a little more interesting. Somebody figure out what the inside function is. X squared minus 7. Alright. X squared minus 7 was put into what function? True. Exactly what though? So they put x squared minus 7 into what form? What did they put it into? So think about this. If I said f of 9 is 1 over 9, what's a one possibility for what the function itself was? F of x. F of x. Yeah, maybe. Yeah, true. But maybe, what if f of 9 is 1 over 9, f of 3 is 1 over 3? I mean, so more directly it would be 1 over x, yes. You can see that. So see how this is really the same idea. H of x is this. What is it made of? It's made of x squared minus 7. That's the g function. X squared minus 7 was put into what? 1 over x. If you put that in here, don't you get this?
Yeah.
So that means that the answer would be g of x is x squared minus 7, and f of x is 1 over x. They took that and they put it in this one. That's all those are about.
So for like 40, would the answer be like function of x equals 1 over square root x minus square root x?
That's one possibility.
Or,
And then what would your g of x be?
G of x would be 2.
Beautiful. So there are multiple possible answers to these.
Okay.
There are many wrong ones too,
How would
but
you know if the square root is on the function of x?
you
or on
don't.
the function of-
So answers may vary, they say right there.
Okay.
Yeah. And the reason they may vary is because you're going to consider the inside to be different things. Right?
Okay.
Okay.
That's confusing.
So let me show you another one. All we're doing is thinking backwards about what we were doing yesterday.
Yeah, I got
So, here we go.
I got that concept.
Here we go. If I got x squared over 7 minus x squared. Can you see a piece of that that's like repeated?
X squared
x squared. So if I consider, so they're asking me, what did somebody put into something else? If I say g of x is x squared, so that's g of x. What did I put that into to make this happen? So wherever I see an x squared, there must have been an x, so that's the spot where I would have put it in. So I would have put it into,
X over 7.
if I put that in here, don't I get this?
Here.
Yes,
Yes.
there.
Okay.
Is that the only where to tear that apart? No. There are multiple ways of giving me an answer, but as soon as you see a piece that looks like it was plugged into a form of something. So what's the form of this? Something over 7 minus something. Bam. What specifically was put in there? X squared. I like it. Now, of course, those are going to be more difficult because it's going backwards. It's easy to put things together. Remember multiplying, foiling? That's easy. Tearing them back apart, factoring, shit. Putting a function into another function, easy. Tearing them back apart, it's going to be a little more difficult. I'm not saying you can't do it. I'm just saying don't beat yourself up if it's harder than it was the other way around. Of course it's going to be.
So you just find a common thing. in
One way to
the-
do it is to look for something that's kind of repeated.
Mhm.
There's some problems like that. But see, there's nothing repeated over here. But I can say x squared minus 7 is in the denominator. So maybe x squared minus 7 was the function I put in. And what did I put it into? A 1 over x function. Then it would have gone into the denominator.
Gotcha.
That is not the only way to do that problem. Yes?
Could you have also said,
Totally? Sure.
Okay.
Yeah, so for this problem here,
There's a GS is X
for that problem there, right here, that was one possible answer. Oh, you just died now? I was here for your death. Oh my gosh. I feel so honored. Okay. So for this, another possible answer would be g of x is x squared.
Yes.
See how I knew you were going? And f of x would have been 1 over
X minus 7.
x minus 7. Because if I put that in here, I get this. So that's the same problem, two possible answers. That's why they say answers may vary. Yes?
So, depending on what the actual format of the thing, whatever it's called, function, whatever, there could be more than 2.
Totally, yes. In fact, to be honest, there's an infinite number of possibilities.
Okay.
One dumb one is, well, I'm not going to even talk about those. There's two main ones, and then there's an infinite number of little variations on those.
I lost it.
Do we need both answers?
No, hell no.
Oh,
Okay.
That's why it says answers may vary.
Okay.
It doesn't say find all the ways. That would be evil because you would list them for the rest of your life, and then your kids would take over, and then your other kids and their kids and their kids. Because there's an infinite number of possibilities. So you only have to take the one that you see and write it down.
would we have to show the arrows telling you where we plug things in? So just
You could do that for yourself if it helps. I don't need it. Yeah. All I need to do is to see your two functions. The g is the inside function that was put into the f. G put into the f. So you can check your work really easily.
I noticed off topic, is 12.2 like word problems?
No, we haven't talked about 12.2 yet, have we? So, well, yes, we have. 12.2 is just exponential functions.
Okay, gotcha.
3 to the x, stuff like that.
So the rest here, like, just single numbers, like,
Oh, I see what you mean. It's just because there are a bunch of graphing problems. You only
Oh, okay.
have to do a few to get the idea.
yeah.
Yeah. Yeah, so don't worry, those aren't like crazy big ass problems I only gave you for. No.
That's,
That's on the file.
Yeah. Let's see. Okay, and then we also got into 12.3. We did logarithms. That's 12.3.
And that's 12.3.
We only are doing one more section before this next test, so you only have to do up through 12.4 homework, which I will give you before the end of the day. I haven't figured out. We'll see how much we do in 12.4. All right, how are we doing? Everybody is with what's happening.
so natural logs is next?
Yeah, the log base 10 in natural logs, they're actually in section 12.5. So that's going to be on the next test. We're only going to make it to 12.4. Yes.
Okay, because that was on the practice.
Yeah.
I know. And as you'll see on the key, number 7 is 12.6. That's going to be on the next test.
Okay.
LN stuff I won't do. How many LN stuff did I have on here? Not a couple. Yeah. Okay. Can't be in the homework because 12.5 is the first place they tell you what it is. Yeah. That would be unbelievably evil. All right. Okay. If there's no other questions, we're going to get back into where we left off. So we got through, like I said, we got through 12.3. Let me give you, let's see, where are you? Did I print that one out? Oh yeah, real quick, if you weren't here, those of you who just got the practice test probably need these handouts also. Let me see, who is that? Whoa. What are you doing in there? Okay. So who didn't get these from the other day? This is, all right, just answer keys for a couple things from before. We might even need some of those. Let's see, is this everybody? Yeah, next week is the last week. Huh?
Oh, yes, it is.
Get some more.
Jumpstart my ADHD.
Not yet, I don't think so.
All right. I printed out that too. Whatever. So let me do this. This is actually kind of a further explanation of the lecture that got us into logarithms. And then there's some practice problems at the bottom. On this side is some practice about the composition stuff and the inverse stuff. So let's do this. Let's do this side, the composition and inverse side. So it just came in. All right. Why don't you guys go ahead and try to do this side, the composition and inverse side. That's a little review. We'll do these together in a minute.